In this video, I'm going to look at some techniques of integration, that is finding the antiderivative. Now, there's quite a few formulas for integrals, just like there are for derivatives. But here we're going to look at the basic idea of what is called the U substitution. Actually, just changing the variable of the integrand just to make it a little bit easier to solve it. So let's look at some of the basic formulas. The integral of, say, 1 dx equals to x plus a constant. Okay, you take the derivative of this. On the right side, you get the integrand over here. So the integrand here is 1. So the derivative of x plus c is 1. Okay. The second one, you have the integral of a function times a constant. This just simply tells you that you can factor out the constant if you like, and then work with what you have here. Number 3, if you have the integral of a sum of 2 or more functions, again, you can break it up into the sum of several integrals. 4 is one of your very basic formulas, basic power rule. You have x to a power. This is the way you compute the antiderivative, with, of course, the condition that n cannot be -1, because otherwise you're dividing by 0. Number 5 is pretty much the same thing as 4, except we're using u to the n. U prime here is the same thing over here on the right as du dx. So if I replace the u prime by du dx, it just gives me du. Okay, I kind of prefer this one right here. Okay, so if I have the integral of u to the n du, that's the same thing as u to the n plus 1 divided by n plus 1 plus a constant, where this should be n does not equal to -1, and u prime equals to du over dx. Okay. And then number 6, your typical integral of du over u. Again, if this is an x over an x, this would just be an x right here. Again, I'm using this method right here, or this notation, because we're looking at what is called a U substitution. So you have 1 over u, the antiderivative, or the integral of that is natural log of absolute value of u plus a constant. Antiderivative e to the u is e to the u, just like if this were an x and this was a dx, this would be e to the x plus a constant. And then again, the next one for the exponential a to u du, integral of that is 1 over natural log of a times a to the u plus a constant. So these are some of your basic formulas. Of course, there's quite a few for the trig functions and so forth. So there's some trigonometric substitutions, partial fractions. We're just looking at the basics for now. Okay, so let's look at some examples. Evaluate each indefinite integral. Okay. So this one, taking the antiderivative or the integral of a polynomial is pretty basic. You just simply go term by term, applying your basic power rule up here that we went over a while ago. So we wanted to do that. We can go ahead and take this to the 4th power and just go term by term, and that's going to work out. But what if this exponent were a 20 or a 30? You don't want to do that. Okay, so here I'm going to do this. I'm going to let my u equal to 3x minus 2. And you find as you go through these examples, when you select an expression for u, it's generally going to be something inside the parentheses, or it could be an exponent. It could be an exponential, maybe the exponent of that exponential, or it could be something in the numerator, or it could be a factor of something in the numerator or the denominator. Okay, so in this case, I let u equal to 3x minus 2. So then what I do here is I find the differential. Okay, and this gives me du, and then differential this over here is simply the derivative times dx. So this would be derivative of 3x minus 2 is 3 times dx. And then the whole idea of using the U substitution is to rewrite the integrand so it looks like one of the ones up here in the formulas 1 through 8. Okay, so in this case, this will be the integral, and then here I'm going to divide here by 3. Okay, so everything has to be transformed in terms of U. So dividing by 3, I use these expressions here now, and I can say, okay, 3x minus 2, I said that was going to be U, so I put a U here, and then that's to the 4th power. Okay, and then dx from this right here, dx is du over 3, so this will be du over 3. I'm just going to put it out in front. It's a constant, so I can bring it out. And then now you have a basic term, okay, just like the word x to the 4th. Integrate that the same way. So we would simply say the integral of this would be u to the 5th, add 1 to the power, and then divide by that. Then you also have the factor of 1/3 here, and then plus a constant. Okay, so you're going to be making U substitutions or solving a problem like this by changing the variable. You want to make sure that in your final answer you always give the answer in terms of the original variable, which of course is x. So then here I simply go through and say multiply this out here. This will be 1/15, 1 over 15, and then u is 3x minus 2, and that's taken to the 4th power, and that's plus a constant. And this is your answer. Okay, like I said, you could have worked it out by simply taking this to the 4th power, and you wind up with 5 terms. And then you take the antiderivative term by term, add your constant, you have the answer. But this is much easier here, especially, like I said, if this is a large power here. Let's clear this. Okay, now this one, you have the antiderivative of x e to the x squared. Okay, so remember, we know the antiderivative of e to the x is e to the x times a constant, plus a constant. Antiderivative of e to the u with respect to u is e to the u plus a constant. So we try to simplify this. So again, we want to select a value for u that will simplify this and put everything in terms of u. See? So in this case, I'm going to let u equal to x squared. Okay, and you'll see why in a few seconds here. So now take the differential of both sides, be du, and I guess on this side just take the derivative with respect to x, 2x dx. Okay, so the idea then is to transform this integrand here so that everything is in terms of u. Now if you have a constant, that's okay, because you can always bring out a constant. So see here you have x dx, x dx, that product there is right here. So I can say that x dx, dividing both sides by 2, is du over 2. So now I have an expression for that. Okay, so now I can just say, okay, this is going to be the antiderivative, or the integral of, and then the x dx can be replaced by du over 2. Again, I'm going to bring the 1/2 over here, okay? And then this is just going to be e, and then x squared, that's your u. Now we have a basic antiderivative here. Now we take the antiderivative with respect to u. This is going to give us 1/2. And then this is going to be e to the u plus a constant. So see, it comes out real easy. Now we just simply have to make the substitution because the original problem was given with x. So all we're going to say is then this is going to equal to 1/2 e to the u, but u is x squared. Okay, and it's plus a constant. Okay, one thing with this these types of problems is you can always check your answer. If you take the derivative of the answer that you got here, it should give you this expression right there, which it does because the derivative of constant is 0. The derivative of e to the some power here, the constant doesn't matter, it's just going to be the same expression times the derivative of the exponent, which is 2x. And I put a 2x over here divided by 2 will give me this answer right here. Okay, so that's your answer. So again, when you're doing these U substitutions, the idea is you look at the integral, and if you see what approach to take, you see it's a basic formula, then you go ahead and solve it. If you don't see what approach to take the way it's written, then try to rewrite it by making a U substitution. And like I said, select your U so that it's something in the parentheses. It could be something in the denominator of the integrand, or it could be a power to one of the terms in the integrand. Let's clear this. Okay, this one, look at this, and again, if this were just x plus 7 in the numerator, there's no problem, okay, but it's in the denominator. So, it should be obvious based on what I said that in this case I'm going to let u equal to what's in the denominator, x plus 7. Okay, so then du, differential of the left side, and then differential of the right side, you just take the derivative times dx. So the derivative of x is 1, 7 is 0, so this will be just dx. Okay, so then, again, just rewrite this in terms of u. If you have a constant, that's okay. You just don't want to have an x or dx in the expression. So this then would be x plus 7 is your u, so I'll put u here. Dx from here is du, so du would go right here. And then of course the 5 is on top there, so I could leave it there. I could bring it outside since it's constant. That's one of your formulas. And then you should recognize this right here as the natural log, okay, of the variable, in this case u. So this is just going to be 5, antiderivative or integral of that is natural log of absolute value u plus a constant. And then always remember to go back to the original variable. So go back to your substitution. U is x plus 7. Go back and resubstitute for u. Absolute value of x plus 7 plus a constant. Again, you take the derivative of this, you're going to get 5 over x plus 7. That's one way to check it. That's your answer. Okay. Now feel free to stop the video if I'm going too fast through these. I want to clear this. Go to the next one. Okay, so this one here, if you look at this, you got x squared over x minus 1 if that x squared on top were just a 1 or a constant, then number 4 would be just like number 3. We would take the same approach and it would come out to the natural log of absolute x minus 1 plus a constant. But this x squared makes it a little bit more involved. Okay, so again, always try, if possible, try to simplify your integrand if possible, sometimes by making a substitution and sometimes just by doing some algebra. Like here, one way to do this is I could use long division, okay, or I could do something like this, which you would get the same answer, but I'm going to do this. I'm going to say this is x squared minus 1 plus 1 divided by x minus 1. So in other words, what I'm doing is just rewriting this so that I could use a formula that I'm familiar with, okay? And basically the formulas I'm using are the ones I just went over at the top of this page here. So now I can break this up into two integrals here. So I'm going to say, okay, this is going to be, and notice here I just added and subtracted 1. Negative 1 plus 1 is still 0, so this is still the same thing as what I started off with. That's a little trick in mathematics where you can always add 0 to an expression. It doesn't change it. Just like you can always multiply an expression by 1, it doesn't change it. So in this case, I can write this as x squared minus 1 over x minus 1. Okay, plus, so I'm just breaking this up here. So these go together over x minus 1, and the 1 goes over x minus 1, 1 over x minus 1. This is going to be two integrals here, so let me do this here. Okay. So this would be just dx here, and this would be another integral over here, dx. Okay. Now let's simplify this. This is x squared minus 1, so I can write that as x minus 1 times x plus 1. Okay, then I say, okay, these two are going to cancel here. So I'll just go up here and say, okay, so this is going to give me the integral of x plus 1 dx plus the integral of 1 over x minus 1 dx. Okay. Okay, so now I simply take that. Now on the first integral, this is just a basic polynomial x plus 1, so I can integrate that easily. This is x squared over 2, and the antiderivative or integral of 1 is x. And this one right here is just like number 3. I let u equal to x plus 7 on number 3. Just let u equal to x minus 1. And it comes out the same way. You can look at those steps as the same. So this is going to be plus the natural log. So this actually comes out to 1 over u du. So this is going to be natural log of absolute value of x minus 1 plus a constant. Okay, so this is This is your answer. Again, your answer should always be in terms of the original variable, which was x. Okay. And again, you could have done this by long division. You could have just taken x squared. Instead of doing it the way I did it, you could have taken an x squared divided by x minus 1. Like this. And so you go x into x squared is x. X times x is x squared. X times minus 1 is minus x. Subtract. This cancels out. This comes out to a plus x here. And then x into x is plus 1. 1 times x is x. 1 times minus 1 is minus 1. Subtract. The x's cancel out. I get a 1 here, so this gives me a remainder of 1. So the quotient here is x plus 1 and 1 over x minus 1. And that's how I got this x plus 1 here and this 1 over x minus 1 here. Okay. I did it this way here by adding negative 1 plus 1, which you can see give you the same answer. Okay. Hope this helps you out. I will continue with some of these types of problems. If you have any requests, please post them in the comments below. And thanks for watching. We'll see you in the next video.